using this answer with no rounding, then this will have more decimals and will be more accurate over A. All right, so sine 40 degrees equals 12. Sine 107.6 degrees. So 12 times sine of 107.6 degrees divided by sine of 40 degrees is going to give me side A, which is, if I found it correctly, 17.8 approximately. Okay, so now our final check. I find my largest angle, my greatest angle is here, A, 107.6, and it is opposite my greatest side. Correct. My smallest side, 10, is opposite my smallest angle, 32.4, so I pass that. Then I look at my two smallest sides, 12 and 10. Is their sum greater than the longest side? Yes, it is. So I again know that this is a workable triangle. Okay, again, pause at this point if you need to go back over that example. I'm going to move on and show you example C. So we've got 30-degree angle, 20 and 10. Again, it's side-side angle as our given information. So step one, find the height of the triangle. I'm trying to color code. So finding the height of my triangle. Sine of 30 degrees will equal my height divided by 20. So my height is 20 times sine of 30 degrees. And working that out, oh yeah, sine of 30 is a half, right? That's a special angle for us. So 20 times a half is 10. My height is exactly 10. Now, I compare that to the given side. They're equal. Okay. So I'm right here. My given side is equal to the height of my triangle. And the only way that that can work is if I have a right triangle. Okay, so in this instance, my side-side angle made a right triangle. So it's easy. You know how to do right triangles, hopefully. The beauty of right triangles is you now can use right triangle trig. So Katoa, and you can use good old Pythagoras' theorem. So we'll finish it with some right triangle trig. First of all, I can subtract these to find our missing angle, which this is B, this is C, so that's A. So I know that C is 90 degrees. So I know that A is 180 minus 90 minus 30, and of course, that is a nice value of 60 degrees. So we've got a 30, 60, 90 triangle. Isn't that nice? Okay, so now you can use Pythagorean theorem or you can use right triangle trig. I see a student in the audience says, I want a review of Pythagorean theorem. I forgot that one. So we would do leg squared plus leg squared equals hypotenuse squared. Not 200, sorry. 400. So A is 10 radical 3. And yes, I didn't need to do any of that work because you guys all remember your special right triangles, and you remember the relationship that the longer leg on a 30, 60, 90 will of course be radical 3 times the shorter leg. There we go. So we have all 3 sides, we have all 3 angles. Let's double check that everything makes sense. Here's my smallest angle. It's opposite my shortest side. Here's my largest angle. It is opposite my largest side. So I pass that. The sum of my 2 sides, my 2 legs, 10 and 10 radical 3, when you add those together, yes, they exceed the longest side of 20. So this checks out. This makes a valid triangle. Again, pause the video at this point if you need to go back and rework C. But I'm going to go on to the last example. At this point, example D. Oops, sorry, 6 is over here. Okay, so notice, by the way, whenever I have side-side angle, I'm always just putting the given angle over here. That way it's consistent. There's nothing wrong. You could draw your triangle differently, but you'll find it easiest if you just always put the given angle in the same spot and always, make this base the unknown value. Okay, find our height. So sine of 30 degrees equals my height over 15. My height equals 15 sine of 30 degrees. We know sine of 30 degrees is a half, so my height is half of 15. Or in other words, 7.5 units. Feet in this case. All right, so my height, it turns out, is 7.5. But this side over here is only 6. Right? So if I made it proportional, my side is shorter than my height. No matter how I turn it, it can't complete the triangle. It's too short. Okay? So I'm right here. My side isn't as tall as my height. It's not long enough to close my triangle. So no triangle exists. That's probably going to be your favorite problem, right? Because it's quick and easy. Okay, so there you go. We've gone through each example. Feel free to go back and review. Feel free to come in, or not come in, but tune in to office hours and you can ask questions on any of these. Thank you.